Good day, everyone. My name is Jason Samuels, and today I'll be presenting on the work on energy usage in South African schools under the supervision of Professor Tinus Boysen and Professor Saki Grobelaar. The overview will include an introduction and context of work, research and design methods of the work, this novelty that the study was dealing with, the overarching story of helping schools, which includes understanding the school's usage, changing the school's usage, and then introducing alternative energy usage in schools, and then I will conclude. As a background, there are three things that feed into the school's energy impact. The first is energy, then there are financial strengths and also disadvantaged structures. With regards to energy, the energy usage of schools in South Africa amounts to about 2 to 3 terawatt of the usage in South Africa, which is about 4 to 5 billion rands worth of electricity, and it is between 2 and 3 billion kilograms of carbon emissions. With regards to the financial strain, schools have tight budgets. They unfortunately have a lack of management and a growing electricity usage and electricity cost. So there are constraints there. And then the school's history is that the poorer schools have been disadvantaged and have been left with disadvantaged structures due to apartheid. And that will have an impact on the buildings, so that either have very poor, low quality buildings and equipment and constricted spaces. So the problem then, we defined it as with the reliance of South African education for the country to move forward and to grow. With the importance of that, how can we help schools with them facing financial and managerial challenges which extend to their utilities management, and then that leads to high bills and a need for skills and resources to manage those challenges. There's also the environmental crisis, where high emissions due to energy usage and other forms of emissions need to be reduced, and schools are responsible, according to my estimation, between 1 and 3% of energy demand in South Africa, which is very coal dependent. So they have a part to play there. The question was then, what is the measures that could be achieved to save energy and costs, and how would this be done if the cost of energy in schools are very substantial and there's a very large footprint for it, and they also have financial constraints. The study was a mixed methods approach to try and answer these questions. However, it was heavily leaning towards the quantitative methods with experiments and analysis and monitoring, and also including some qualitative methods, where we interviewed principals to get a broader context of what is happening and to determine the flow of information with regards to electricity usage. So the novelty of the study is expressed in 4 different contributions. The first is the making known of unknown energy or electricity usage in South African schools. Before, there was no published data of South African schools' energy usage to this extent, with regards to temporal visualization of their profiles, as well as the comparison between other schools globally and locally. The second contribution is the reduction that was made through our experiments in the schools with regards to efficiency and behavioral interventions. Third is the contribution of the impact of COVID-19 measures on the schools and how it translated to energy in schools. This was not published before. And then lastly, the fourth contribution is the impact of PV in schools, specifically in Stellenbosch, where it was expressed in terms of the carbon emissions and the cost of the PV impact in the school, as well as the discrepancies between simulated and actual yield for that school. So the overarching story is then to understand the current usage in schools, then attempt to reduce it or understand change of usage in schools, and then lastly to understand the role of alternative energy, specifically solar PV, in a school. So to start off with, we compared the school's energy usage over a year for a specific area of the school with schools in the literature globally, and we saw that was a difference, that our schools were using way less, and then even more, the poorer schools were using way less than the richer schools, more than half. Here is a picture of the richer schools, the quintile 5 schools with very big areas of school premises, and then the quintile 3 schools with more constricted areas. So their areas are very different, and the approaches to energy efficiency in these schools would have to be different in some ways and also the same in other ways. It would be the same where the concepts of reduction and sustainable behavior would be promoted in these schools. However, with regards to the specific items, the specific facilities, financial management, and the carryover of information, it would have to be different for the affluent and the poorer schools, as they do differ in terms of those mentioned things. Here is the temporal usage of the schools in our sample set, and you can see a clear difference between the richer schools and the poor schools. We expressed it per learner per day, and yeah, it is quite substantial. So although our energy usage over the year for the area of the school is very low compared to other countries, this does not indicate a very high efficiency, as there is an infrastructure lack in many of these schools. So that's where that's what we concluded, that the reduced energy intensity of these schools are so low due to lack of investment in infrastructure. And although it is low compared to other schools globally, and although it differs between richer and poor schools, there is still a gap to have energy efficiency interventions benefit schools where they could save and where they could reduce costs through efficiency and behavioral interventions. So the observed ways of change included two active ways of change, which were the efficiency and behavioral interventions, and one observed passive manner of change, which was the occupancy. So firstly, the energy efficiency impacts were investigated, and this is a school that we worked with. Its name is Clutesville Primary. We did an energy audit and saw that that a low hanging fruit was the old fluorescent lamps. And we further did energy audits at other schools, and this was a repeated pattern, that schools have many old inefficient lights. They do have other equipment as well, but the lighting items far outnumber the other items in terms of energy usage and sheer quantity. And here is a good point to mention that lighting is a internal environmental quality that should be defined for the healthy and productive environments in class, or to create such environments in classrooms. And my base case is that there should be some minimum parameters with regards to lighting quality, with regards to lighting levels, and also color temperature of the lights. So as mentioned, energy audits were done, and in the poor schools, yeah, there were computers and printers, there were some air cons, but there were many, many, many lights. So for the schools with air cons, they could possibly have heat pump replacements. I do think, though, that such installations need to take into account the climate where the school is in, to ensure that the efficiency of the heat pump does not decline, as well as the infrastructure needs to be adjusted, in my opinion. However, the impact could be made in terms of lighting, as there were many lights, and this is what we found investigating schools in our sample set. The amount of cost of electricity that the lighting represented were between 31 and 57% of their total cost, and we could reduce their bill between 21 and 39%. We then further had a model created for the lighting energy usage of schools, and we also validated this model with projecting the usage and also measuring the usage afterwards. And if you look at the third figure, you can see the difference between the measured and the projected usage is less than 3 or 6, actually 6 kilowatt hours in total, which is a small margin. The behavioral interventions were then our next step of energy reduction, and the specific measures that we did were two main things. The one was training, and the other one was the reporting. So firstly, for the training, to improve their energy consumption through influencing their behaviors, training was done with the school staff regarding climate change, regarding how electricity works, and regarding their tariff structures. And the second method included the frequent reporting to treatment schools with control schools as a base, where this experiment would be implemented. And this would be frequent reporting in terms of daily reporting, weekly reporting, and then a month of reporting with regards to their energy usage. We saw that there was a 11 to 14% impact and reduction in their energy usage. And here, the material actions are unknown to me, as we only had the bulk measurements data for the school. But a good guess is that their loads were shifted, and this is also what some of the data then shows, where peak loads are shifted towards the off-peak times. The last observed method or manner of energy usage change was the occupancy, and this was given to us in opportunity by the pandemic, where we could evaluate the consequences of the pandemic on energy usage, specifically in schools. These are some of the students in the schools, and they were unfortunately not very implicated or involved in the study, as the responsible people for energy decisions in the school were the school staff. They were also not involved in the monitoring and the data collection activities. However, these concepts and ideas and behaviors are very important to be transmitted to them, so that is cultivated to build sustainable behaviors in our communities. Here is the 2019 energy usage compared to the pandemic energy usage. And what is prominent is that the 2019 was at larger usage, at greater usage, and in 2020 there was a reduction. From April to October, there's a 33% reduction for schools with hostels and a 25% reduction for schools without hostels. Here, the lockdown dates are plotted and overlaid on top of energy usage, and there is a reduction when the schools were at hard lockdown and there were no occupants at the schools. However, there's still a minimum usage detected of about 6 kilowatt hours at the schools, which is very interesting and a point to explore further. So this is the delta, the difference of the energy usage normalized, and it's between 30 and 40% during hard lockdown, where their energy usage was reduced, which results in quite a bit of money, monetary savings for the schools. And then lastly, we looked at a case study school for solar PV in the school, and this is the yield for a couple of months of PV energy usage at the school, and yeah, the usage was then compared with other years of usage to see what the impact is of this usage, and it was approximately one ton of CO2 saved per day, which translates to about 230 rand at about 650 kilowatts per day. Here the interesting thing was the simulated results compared with the actual PV yield actually had a difference of 12% on average when considering all of the months. So with concluding thoughts, I think it is important for schools, in order to reduce energy consumption, to have their heavy power usage items replaced, and the items that they have a lot of, such as lights, and have them replaced with specific LED lighting for them to save. This would include inside lights as well as outside lights. And then schools should adequately switch off their appliances and their usage when they would have to leave, in terms of hard lockdown or in terms of holidays. I also do think that schools could be net zero, and this would include the whole overarching story where the usage is understood, and they then further manage their usage and reduce their baselines and introduce solar to offset their energy usage that has carbon emissions. Yeah, as other concluding thoughts, the findings would be recommended to the Department of Education to have smart meters installed, to have lighting retrofits done in all the schools, and then to have periodic reporting done and implemented to have schools save and reduce their energy usage over time, and only then would the PV be introduced, as well as these efficiency measures being implemented. Schools also need to be trained with regards to how electricity works and efficiency behaviors. There is so much more to do, so we've started a company in order to help the schools and to help other buildings as well. And then lastly, I'd just like to acknowledge the contractors, sponsors, examiners, and the supervisors, the government, municipality, university, and the research group. Thank you so much for listening to my presentation, and yeah, I hope you go well. Thank you.